Hi, this is Nick with some more woodworking. Okay, today we're going to set up a spoil board. I already got the board here and I got it mounted. I'll tell you what I did. So, board is 32 1/4, so it's a little bit bigger than the full working area. And then the full width, it's 49 inches. MDF comes a little bit bigger than the 4 foot. It's like 4 foot 1 inch. So I left that so I can put my mounting screws just outside the area. You can see them here. Then what I did is I took the factory edge. You can see I put an F right there. Make sure this is as straight as possible. And then these are obviously both factory edges. The only one that isn't is back here. And I took my machine and I used some Etch-a-Sketch mode. So I used a V-bit, and you want one that's more aggressive but not too crazy. So this is a 60-degree, I guess 90 would work too, but I wanted something that would point as much as possible. I put it in my machine, and I already did this, so I didn't want to redo it. I just walk you through how I did it. So I ran it all the way up here, as close as I could, and then got it all the way against each area. So it has this bit, and the reason why I used a V-bit is because it comes to a perfect point. Obviously you can't do it with the flattening bit, and I'll show you why here in a second. Is I ran it like that, so Etch-a-Sketch mode. So I ran it back and forth. So if you want it only to go just plus Y, minus Y, if you hold this guy down, then this one doesn't work, see? And then if you want it just to go in the X directions here. So what I did is I had my bit and I got it to where it was zeroed to respect with this surface, so this board was out of the way. I got it zeroed to where it was zeroed with this. I put my probe down, probed it, and then I ran my bit. I ran my bit like this, and then like this to show me exactly the edge of the working area here. I ran my bit like this, and actually with this I went all the way across. So I knew the exact edge of my working area. If I use this actually goes out farther than my working area. I mean, I know the program can account for it, but it's not going to leave me a nice crisp line. And then over here I did the same thing. I left a line right there. And since this is wider, you can see this is where the lines actually come out to, right there. I drew them with a pencil here because obviously the machine can't reach there. And then same thing here. I took my wasteboard then and brought it up and right along the real, so this isn't the line here, the real line's up there. This is what I used to set my gantries and get them all squared up, a good reference point, because this one was fixed. I have it in another video, you can see how that is all set up. But I set this board down, I know that this is straight from the factory, and I ran it along this line, and then I just made it even for the parts hanging out so I can put my screws there, which are recessed there, and secured this guy down. Then with the flattening file, which I have available on Etsy with the grid markings and that, we're going to walk through it today. I took my zero down here in the bottom left. I found that's the best since it technically has, was it 48.5 or 48 1/4 inches? Just wanted the 48. I zeroed it from way down here and then let it do its thing. It already did one pass. I'll run through another pass so you guys can see. It flattened my wasteboard, and what you need to do is when you're flattening, make sure there aren't big ridges either way, either with respect this way or with respect this way. That might mean that you need to do some tramming depending on how accurate you want to be, but I mean if there's big ridges that you can really feel with your fingernail, then you might need to tram. Hopefully in a future video I'll go over how to do that. Mine didn't turn out bad, so I'm not really too worried about it. And then also this is a good time. I had some growing pains with seeing how my dust hose is going to react to being, you know, coming from over here, way over to here and moving around. It was getting wrapped around this, so I got to do some alterations there. And then also making sure your wires are clear, nothing's getting pinched under here, nothing's going to get caught, you know, and then throw off your machine, possibly break something. It's a really good time to watch and learn from your machine where it's naturally going to, you know, if your power cord here has a twist in it or you didn't straighten it out, or maybe you want to twist it, it will react different ways. I ran mine inside of here and it turned out to work all right. What I did find, however, is I don't have enough room to plug it up underneath, so I ran it on an extension cord currently, and I'll either put another outlet, say up here or down below or something else, maybe put an extension on this cable to get it to work the way I want it to. But I found that out because when it went to this back left corner, it was just a little too short, unplugged it, and yep, that happened. So not the end of the world. I was watching it, I was ready with the oh shit button to shut it on down. But yeah, I ran that out, and then what my plan to do is, obviously I've flattened this side, that's fine and dandy. I want to put in the threaded inserts, which a lot of other people use. I don't use them as much anymore. I mainly screw down my pieces of work or use the double-sided tape, but I like to have them just if I want them. What I'd like to do, and this would be different from what I did last time, is I will drill down the through hole for those from this side. Like last time when I did it, I had this board upside down, I did it all, and then I flipped it back over and flattened it. I'm thinking this time what I'm gonna do is I'm gonna drill just the through holes on this side for the threaded inserts. And then what I'll do is, I know like my first threaded inserts at 2 inches and 2 inches, I'll put my machine at 2 inches, 2 inches when I flip this, and then I'll flip this thing over, get my bit, and have the machine line up right there, and that's right there, and I can screw it down then. And obviously this will always be true, but side to side may not be. I may not know where that is. Since this is a factory edge, it doesn't matter if I have it flipped one way or the other, it should line up. But what I don't know is side to side where it's gonna line up. So if I do that and I look on this machine and I make sure I get it to 2 inches and 2 inches, if I come straight down, I should be right over that hole. And then I can drill out the recess for the back part of the threaded insert, which will actually be facing up once it's installed. So that's my plan so far, and then I'll flip it back over obviously, and then secure this side down, and I'll be ready to go to start putting on my grid. And that way I can also make sure that my grid and my 2-inch, they'll all be lined up perfectly for me. So I will run this flattening for you, walk through what I did to start it, and I'll just have that as a little time lapse, and I'll run through it. Okay, so it's all completed. You saw a couple times I had to fix this from being over here to over here, so I'm gonna mess around with my dust hose up there. I actually cut out some brackets up there to hold it, and maybe I'll do something else, maybe put a little bungee cord up there. But anyways, besides that getting caught up and that cable being a little too short, everything else is pretty nice. So the reason why I ended up building a torsion table is because it's going to hold its overall shape the best. I know you want to build on the flattest surface absolutely possible. That's what I tried to do. So the table would come out as flat as possible, because once you make this, it should not move. If it does, you got bigger problems. With that being said, whenever you run this path, I cut out 0.02 inches to flatten this board, and I watched it the entire time. You can kind of see, I don't know if maybe on the camera you can't see, but you can see the lip here, and that kind of tapers off a little bit once it gets to the front. And I think it's because the screw's sucking it down a bit, but the table's not gonna be perfectly flat. That's why you do the flattening pass, so that it makes it flat with relation to your machine itself. If you don't have the best lighting or eyes, or just in general, what you can do is you can get a pencil and you just scribble back and forth, and that'll leave you an indication. When you go around, you'll see the pencil obviously disappearing. If I got all the way through this and say over here, which this was on my last table that wasn't a torsion box, this side all got really flattened, and then this side didn't look like it was touched. What you got to do then is go down again. Is you start, and what I would do is zero from over here, and then go down 0.02 inches from there, and then you keep going around, going around, going around, and get it to where your entire area has been touched and material's been removed, so that you know that it's flat. Because if it only removes over there and over here it doesn't touch, well, since that area was not touched, there's no way to know how parallel it is to the machine. Obviously, it's not going to be parallel to that surface, so you need to cut it out. Now, what I think I will do is get into my file and I'll load in the grid pattern and cut that out. And then also right after that, follow that up by by cutting the holes for the threaded inserts. And remember, I'm not going to put them in from this way, obviously, but I want to cut those holes, flip this over, line it back up, and then cut the bottom part to actually accept those holes and make it so this board can still lay flat. Okay, so here you can see we have drilled all these holes here. We got all these, so if you look, these are the threaded inserts that I use. You kind of see them. I'll have the link for them. They're on Amazon. Just about everybody else uses them. They're 1/4 inch by 20. So 1/4 inch and then 20 threads per inch. So if you look, got these little guys here, and these will actually be pointing up like that. This top hole that you see here is actually, it's right there, it is to fit straight through. So what I like to do is I drill this part first, and if you look through it, it fits right in there with a slight bit of slop. I have the file for this and that, so you guys can probably figure it out too. It's not the hardest thing in the world, it just takes a lot of time. These all fit through there. Now, the other thing I'd like to do is, you can obviously lift up the board and hammer all these in, but you're still going to have, you see, you're still going to have this part right here. That part right there is still sticking down. So I like to countersink that so that's actually flush. But doing that, you got to flip your board over. It's kind of a pain in the butt, but I've got a decent system to do it by. Since this is all based off of the bottom left-hand corner going up, I want to flip this upside down. Then obviously, since this is the factory edge, we'll have no problem lining that back up, but we won't know which way here to go, right? Although I have it marked, it just may not be the perfect distance here and here, which, I mean, it'll still get me damn near in the ballpark, but I like to try to be as good about this as I can. So flip this over, and then what I'm going to do is, I've already zeroed my machine. I'll bring it up to, and we'll get the board lined up with this line, not the one you see right here, but the one that's closer up there. we will get the board lined up with that. And then the only thing we don't know, like I said earlier, is which way, how far one way or the other. I can get it damn close, but it may not be perfect. And what I'll also do is put a little tiny mark on either end here, which will get me even closer. But when I flip it upside down, I'll bring the machine to 2 inches and 2 inches in the X and the Y. And then I'll bring my bit and slowly lower it down and get it to right there. Make sure that everything's square, and I'll screw it down upside down. And then just to check, I'll bring mine, so this is 44 inches, and obviously 2 inches up, so 2 inches, 44. Check that, or I can go with 246, either one. And make sure that everything's square, then screw this side down. And then for that, I'll only put another screw on either side because this is just to hold it, and then it'll cut out just the little holes to hold these guys, that little countersink. And make it a little time lapse so you guys don't have to suffer through all that. But that is what I'm thinking. I think that'll work out the best for me in my situation. You guys might find something different to work for you. But we'll get started on that and hope for the best. Thanks. Okay, quickly, got this thing flipped over. I have not checked it yet, but I did flip it over. As you can see, all I got is the holes here, nothing fancy on this side. I do have a couple other little tiny screw holes, and that was from a couple projects I had to do between filming of videos. Had to cut them, so, you know, board doesn't look as pristine and look a little different from last time you guys saw it. But anyways, back to the problem in hand. Now what I'm going to do is get this controller to 2-2 and make sure that it lines up here, and very, very, very gently push my bit through there. Secure down this side. Bring it over here to 46-2 or 44-2, whatever you feel like. Doesn't really matter to me. Secure that down, and this only works if your machine is square. If your machine's not square, well then you'll know real quick this will push out or push this way, and then you need to go do some homework and get it the right way. We do have a video on how to set up your machine and check if it is square. I'm not going to go into it too much in this video, but that is a good indicator whether or not your machine is square. So I know there's ways to do it in G-code to get your controller where you want it. I'm just going to do it for the everyman, just use my little controller here. Okay, I brought you guys in for a little bit of a close-up view, so you can see here where my X and Y are currently. Z is at 0. I have homed everything, so we're good to go. Make sure that you do home your machine beforehand, or this is not going to work. So I'm going to get my controller. I'm going to bring it in. If you didn't know this, I'm going to make a tips, tricks, but this is fast speed here. This is medium. This is slow. If you select it, it switches how fast you're going to move. Here's a quick overview. I'll move you up and let you see the machine. So if I press this one, see it move. Oh, gotta turn it on too. That always helps. See, it kind of flies. Press that guy. Average speed. And the next one's hard to see. So when I do go to this next slower speed, look at this guy, and it's also a good tip to notice whenever you are lowering down your Z, if you're doing it this way, not using a probe, look at this and you can see if this coupler's spinning. You can watch this and see when it goes down, like right now. Going fast, obviously it's easy to see this, and you can see this moving. Now, don't put your finger in there. I'm going to switch it to slow. Watch that same spot. See, it's slowly moving. Like, it's really hard to see that. You can hear audibly, but yeah, might get a little impatient, wonder. Anyways, I'm gonna move it in close. Okay, so I got it pretty close to where I want it. Now I'm gonna switch to the medium speed. looking here and here, I'm 1.8, 1.95. I'm going to switch to slow because that is almost nothing to move. So Y, I need to go that way just a hair. I mean, 3 digits of resolution, 1.999. That's pretty damn good. Okay, X, I need to go a little bit more that way. To the right, which would be positive X. Oh, right on the money. So there we go there. I'm going to slowly lower it down. Which actually I'm not that close yet, so I'll go a little faster. Okay, so the other thing you can see is this hole, this is a 1/4 inch bit. This hole is a slightly larger than this bit, so when it goes down, it actually goes around a little bit and doesn't just go straight down and peck. There's a bit more taken out, because I think the inside of this is a 1/4, so the outside is going to be slightly bigger, which it does fit in these holes here. With a little bit of love, but that's the way I want them to fit. So anyways, I'm going to look at this and make sure I'm right visually in the center of it. I mean, I'm not going to get it 100%. You can do it all from this side. I just don't like to, because then I don't know if it's lined up with the other side. And this side isn't nearly as critical, because the other side you're going to see, right? This side here you're not going to see. So even if I cut this circle here, circle flange, make sure I got this right here, in freedom units, it's 0.692, at least on my calipers. Let me make sure they're, there we go. 0.692. I think I cut these at 0.72, so I got a decent amount of wiggle room. I'm pretty content with this right here. This looks pretty well centered. Just move it just a little hair. And that, ladies and gentlemen, I believe is on the money. So what I'm going to do, be safe, don't keep your hands anywhere in here, especially if you're moving it. I'm going to push this up, get it out of the way, and then I want to screw this down, but I don't want to just run a screw through, because if you do, it could walk, you know, it could move on you. Don't want to do that. If it does, then you just lost everything you did, then you got to double check. I don't want to reuse that same screw hole, because remember, this board is flipped upside down, so that screw hole actually lines up over here, and this one lines up over there, and then if I come too close to that, it's going to suck my board one way or the other. So I'm just going to set one over here. This one's not that big of a deal. It's not going to be used again, except for this part right here. Okay, and then these bits here are really nice. They actually got the countersink in them, which for this part, not a big problem, but when you're on the other side, it's really nice. I'll still use a little bit of the countersink. So, and this program is only going to run over here, so I'm really not worried. I could do it over here, it's just going to not look nearly as nice when I flip it over. So I'm going to start here. And remember, the premise behind all this is if we're following this line, board is flipped over, this is a factory line, I line up this guy, I line up this guy, there's no other way this board could be off unless my machine is off. And if my machine's off, you got problems. And this also, I guess, assumes a repeatable zero. And if you look at people's other videos, I'm not going to do one on it. They've done the zeroing with the current drives, the current limiting drives, how they find the zero on these machines, and they found them incredibly repeatable, more than I would ever assume. So I'm going to take this machine at its word. Okay, this is secure on the line. Happy about all that. Now I'm going to get my tools out of the way, get everything out of the way. All right, remember, we're still making sure we're on this line. We're secured on that corner there, so the only thing it is it's going to rotate on that axis there. Now we're at 2 inches in the Y direction. Now in the X direction, pick this hole or this hole. It's not really a big difference. We've already moved so far away from that origin. I'm pretty happy with wherever we line up. We'll just pick this guy since it's a lot closer. So we're going to go to 44 inches. And I'm also going to, since we're pretty close, I'll slow down to medium speed. Alright. So we're at 44.021 and slow down the slowest speed. Overshot it a little. 44.01. 44.003, so that is the money right there. We're going to go down. We can go down a bit faster. Okay, looks like we were in there. Looks like we need to go back just a hair, so I will do that. Like I said, this line is going to get you close, but it's not going to 100% set you up exactly where you need to be. I'm going to find where this looks like it's in the middle, which looks like right there. And I will bring this guy back up, get him out of the way. Now, drill. Obviously don't want to use that hole again. So go down and then keep coming back up to get your material out of the way. And then whenever you do this, make sure that this edge is pulled down. So you also know that we did flatten the other side of this board. So whenever you do cut these countersinks in, realize that this board is not parallel to this machine. So say you had it, you know, off by like 1/10 of an inch. By the time it gets over to here, it's going to be cutting out a little more than 1/10 of an inch. So if you notice on your other passes on the other side that you were off by a tremendous amount, then you're going to want to maybe split these hole cuttings up, and, you know, each take a 0 from here and do it, and then take a 0 from here and cut it, and take a 0 all the way down, so that you aren't cutting an extra 1/10 of an inch and just having this insert sit in there. Mine was so far on that I'm really not worried about doing this practice. But what I'm going to do is secure these two back sides here, then start up my program, and I'll go over the specifics after that's all done. I'll give you a nice little time lapse just to watch it happen real nice and fast for you, and extremely slow and painful for me. So let's get to it. Okay, so this all finished up. I just had to do a little rough sanding for it. Wasn't too big of a deal. I didn't use the sharpest of bits to do this because this is just, doesn't matter how great it is, no one will ever see it. And as long as it cuts good, it's good. So after this, what we'll end up doing is taking all these little threaded inserts and making sure, we'll first look over and make sure that that hole we just drilled is pretty well centered over the other. So if your machine is not square, they will not be, and when you try to send this threaded insert home, it will not turn out flush. With mine, I looked it all over and they all seem to be great. You can also open up your tolerance on these if you don't want to mess around with it, but this is a very good indicator whether or not your machine is square. So I'm going to send this one in. So there we go. It is nice and flush right there. Obviously make sure all the debris is out of these holes, but right here it's flush, it's good. So when I flip this over, this machine surface, which is what I trimmed everything out on, will be the prominent surface that is shown, and we'll make sure that these aren't raising it randomly. It might be a good idea to, just in case, if these are a little proud, either to rerun your program while you already have it here, slightly deeper or slightly wider, or when you have this board flipped over, to flatten the wasteboard. Some people will not flatten their wasteboard at all until they get this flipped over and then do it. I just wanted to do it because I had some other work I had to do, and I don't think it really matters. I know that obviously it's not going to be as high as these corners. Remember, these corners right here never got touched because it's wider than 48 inches. But that is all for today. This is all ready to go. It's just going to get flipped over, screwed back down, and we're good to go. You got threaded inserts. I'm not going to put them all in here today because I'm still waiting on Amazon to ship the rest of mine, and who knows when they'll get here. So just want to get this video out. In the future videos, I'll show you it already working, but I already walked you through everything else. Nothing too much else to this. But when you do flip it over, make sure that obviously you follow this line. And since you already made these other holes, when you flip it over, you can line it up with the hole that you made in there, and it should suck right back down to where it was. But obviously follow the line, make sure that lines up with that, and you'll be good to go, and you'll have a wasteboard that you're happy with. And maybe next time, if you don't feel too excited about having these threaded inserts, you'll skip that part. I'm still adding it in, but majority of the time, I either hold down my project by putting screws on either side, or I use double-sided tape. It just depends on what the project is. There are odds and ends ones where I end up using these threaded inserts, so I guess why not put them in. I think in a future one I might just put them, instead of every 2 inches square, I might do every 4 inches square or something like that. Especially with the Journeyman upgrade, I don't think it's going to take a long time to hammer all these in. That's going to be a lot of fun. So until the next one, thanks again for watching this video. If you could, I'd really appreciate a subscribe, a like, share, anything like that. Lets me know I'm doing great. It costs you absolutely nothing. It's really, really super easy. Just click the subscribe button, and it lets me know I'm doing the right thing, and I'll keep these videos coming, and hopefully you guys learn something. If you could, I'd really appreciate a subscribe, a like, share, anything like that. Lets me know I'm doing great. It costs you absolutely nothing. It's really, really super easy. Just click the subscribe button, and it lets me know I'm doing the right thing, and I'll keep these videos coming, and hopefully you guys learn something. Thanks again. This has been Zamora Woodworking, and I'm Nick. Until the next one. Later.